Let's look at some examples of graphing sine functions. Just to kind of as a quick review, remember that our sine formula, our sine equation is y equals a times the sine of the quantity k times the quantity x minus b, closing all the quantities and then plus c. Okay, so remember the a is the amplitude, k is related to the period, b is our phase shift or our horizontal shift, and c is our vertical shift. So I'm going to start this example here by just listing out our values for our example. So our first example is y equals 3 sine of x plus 1. So in that case, our amplitude is going to be 3. The k value is just a 1 because there's nothing in front of the x. We assume it's a 1. The b value is 0 because there's nothing being added or subtracted to the x. And then the c is a 1 because that's what's being added after everything outside the parentheses. So to draw our graph, and I just want to focus on making sure we can draw one period of the graph, we'll start by drawing the midline. Okay, and remember the midline is our c value. So in this case, our c value is a 1. So we'll just kind of put a dotted line here. This is at y equals 1. Then our amplitude tells us how far above the midline and how far below the midline we're going to be. And so in this case, if we have an amplitude of 3, we're going to go 3 units up. So we're at 1, so we're going to go up 3 units, so 2, 3, and 4. So that means the top of my graph has to be at y equals 4. And if we go down 3, that's going to be 0, -1, and -2. So the bottom of the graph is going to be at -2. Okay, so my graph has to be centered at y equals 1. It'll go up to 4, and it'll go down to -2. The next part is I want to figure out where does the graph start. So just where does one period start? And the easiest way to figure that out is just use our b value. So in this case, there's no horizontal shift. B is 0. And so that's going to correspond to x equals 0. And so we're going to move to the left and to the right. Or sorry, we're not going to move to the left and the right. We're centered at x, starting at x equals 0. I then need to figure out how long this graph is going to go. Okay. Normally, the standard period for sine is 2 pi. And since my k value is a 1, that value has not changed. Okay, so my period is still 2 pi. So if we're starting here at 0, oops, so if we're starting here at 0, I need to travel a distance of 2 pi. The graph I'm using here is not scaled in any way, so I can scale it however I want. So let's say every 4 lines is a distance of pi. So there's pi, and then we'll go 4 more. 1, 2, 3, 4. So here is 2 pi. You can scale it however you want. I just like going big so I can have a big picture. Okay. So we're going to start at 0 and end at 2 pi because that's the length of one period of the graph, and we have not affected the period of the graph at all. So if we remember our standard sine graph, it starts at the midline, it goes up to 1, down through the midline again to the bottom, and then back up to the midline. Okay, so I'm going to draw that same thing here. It's going to start on the left edge of this box. So I have this big sort of rectangle here. We could kind of picture it in here. So we have that big rectangle there. It has to start on the left edge on the midline. So that's going to be right here at the point 0, 1. Or sorry, 0, 1. And it's going to end on the midline at 2 pi 1. It's going to cross the midline in the middle at pi 1. And so it has to hit the maximum but halfway between 0 and pi. So it's going to hit it up here. So this is at pi over 2, 4. The middle of the graph was at pi 1. So the bottom of the graph has to be between pi and 2 pi. So it's going to hit down here. So that is going to be at 3 pi over 2 and a negative 2. And then it's going to be at 2 pi on the end. So that's that last point is going to have room for it. It's going to be 2 pi and 1. And then we're starting at 0, 0. And then we get in the way. So my graph is going to start here at 0, 0. So it's going to start at 0, 1. And it's going to go up to the top, up to 4. It's going to go down through pi 1. It's going to go down through all the way to 3 pi over 2, comma, negative 2. And then it's going to curl back up to the midline at 2 pi 1. So that's what the sine graph looks like. Okay, it has been shifted up 1 unit, and its amplitude is 3. All right, let's try another example using some different transformations. So this time we have y equals the sine of 1/2 times the quantity x plus pi. Okay, so let's let's start out by listing out our amplitude. So there's nothing in front of the sine, so it's just a 1. This time the k value is 1/2. So it's not 1. So because it's not a 1, I want to go ahead and figure out what does that tell me about my period. So we can figure that out. The period is going to be 2 pi divided by k, which means we're going to have 2 pi divided by 1/2. And to divide a 1/2, you flip and multiply the reciprocal. So 2 pi times a 2 is actually going to be 4 pi. So the length of this graph, to just do one full cycle of the graph, one period of that wave, is going to cover a length of 4 pi on the x-axis. Okay, and then let's go ahead and keep going. So our phase shift, b value, we have x plus pi in the equation, which means our phase shift is actually a negative pi, right? We always do the opposite sign, so it's a shift to the left. And then our vertical shift, there's nothing on the end there, so our vertical shift is just a 0. Okay, so when we graph this, we're going to again start with the midline. So again, in this case, the midline is 0. So the middle of our graph is just running along the x-axis. The height of the graph is a 1. And since we're not scaled here, I can draw the 1 wherever I want. I'm going to put the 1 4 units up here. So kind of something up there. And so we're going to go negative 1 down here. Okay, so the graph has to be between negative 1 and 1 as it goes up and down as it goes through that period. Okay, the graph has to start at negative pi and travel a distance of 4 pi. So that means if I start at negative pi and I travel a distance of 4 pi, so negative pi plus 4 pi is going to be 3 pi. So it's going to start at negative pi and end at 3 pi. So let's do 2 tick marks in the x direction as a full pi. So this one here is a negative pi. This would be pi. This would be 2 pi and then 3 pi. Okay, so kind of finish our little box here. Okay, so we have this big rectangle, big box that we're going to work with. We know, again, the graph starts on the left side on the midline, and it's going to hit the midline again right in the middle, and it's going to hit the midline at the very end on the right side. So it's going to hit the midline 3 times. Because the amplitude is a positive, it's just a 1, we don't have to reflect the graph, so it will hit the maximum between the first and second x-intercepts. So it's going to hit it right there at 1, and it's going to hit the minimum between pi and 3 pi, so it'll be down there. Okay, so we just connect our dots, and then I'm going to go ahead and label my points, and we'll be done. So again, my first point is negative pi 0. Okay, the midline is 0, and we're shifted to the left pi. The last point is 3 pi 0, because again, we're not shifted up or down, it's 0. and 3 pi is a distance of 4 pi from where we started. Right in the middle is pi 0. And between negative pi 0 and positive pi 0 is our maximum. So that's actually 0 in the x direction and 1 in the y direction. And then our minimum is halfway between pi and 3 pi. So that would be at 2 pi. And that's going to be 2 pi and a negative 1. Okay, so those are kind of the 5 main points. It's where it hits the midline or the x-axis, where we have our maximum value and our minimum value. Okay, all right, let's try one more, and then we'll be done. So in this case, we have y equals, excuse me, y equals a negative 2 times the sine of 2 pi over 3 times the quantity x minus 1, and then plus 3 on the outside. Okay, so let's follow the same process. I'm going to list out my amplitude, which is a 2. So that, again, amplitude tells me 2 units up and 2 units down from the midpoint. It is also negative, which means I need to reflect my graph over the x-axis. Then we'll go to k. K is not the period, but it's related to the period. So k is 2 pi over 3. And so if we try to find the period, we're going to say the period is 2 pi over k. So that's going to be 2 pi over a 2 pi over 3. And again, to simplify that, we're going to take the 2 pi in the numerator and multiply it by the reciprocal, which is 3 over 2 pi. The 2 pi's cancel. And so we're actually having a period of just 3, which is different, right? This period is actually a whole number. It doesn't involve pi. All right. Then let's look at our phase shift. In this case, we have x minus 1, so our phase shift is 1 unit to the right. And then our value of c is a plus 3. Okay, so my midline is at 3. So I'm going to draw in a 3 line here. So 1, 2, 3. And then my amplitude is a 2. So 2 units above 3 would be at a 5. So we have another line here at 5. 2 units below 3 is at a 1. So my graph has to be between negative 1 and 5. Everything, the whole wave is always between negative 1 and 5. Okay. So next, let's figure out where the graph starts. And it starts, the left edge of the graph is at our b value. So this graph was shifted 1 unit to the right. So we'll just go by tick marks. So here's 1, 2, 3, and 4. So right here is, okay. And I know the period is 3. So if the graph starts at 1 and it travels a distance of 3, then we're going to end at 4. Okay, so that's how long my graph is going to be. I'm going to change my grid a little bit here. We're going to go 2 ticks. No, don't really want to do that. So anyway, so we're going to start at 1, and we're going to end at 4. So my edge of my graph here is 4. So this one is a smaller box that we're going to work with, so we got stuff to squeeze it in there. But the same process still works. It's going to start on the left edge on the midline. It's going to end on the right edge on the midline. And it's going to cross the midline right in the middle. It's also going to hit the maximum. Well, normally, so here's where it's going to change. It would normally hit the maximum between the left edge and the middle. But because it's reflected, it's actually going to hit the minimum. So it's going to start in the midline, go down, back up to the midline, and then it's going to go up and back down. So the reflected graph is going to look kind of like that. Okay. So again, we just have to remember when we have that negative out front, the midline, the 3 points on the midline stay the same. You just have to flip where the min and the max are going to be. Okay, you do the minimum first, then the maximum. So last thing here, let's just go through and list our coordinates so we know what our coordinates are. This will be a little trickier because there are 5 points, but we're only traveling from 1 to 4. Okay, so one way to figure out what the x values are, if they're not nice, going to be nice whole numbers. In this case, they're going to be fractions. Take your entire period. So to find the width of each of these values, take your entire period, which in this case is 3, and divide it by 4. It's always the period divided by 4. Okay, this is not the whole graph, it's just how far you have to travel between points. So my first point, again, was based off of my phase shift, which is a 1, and the y-coordinate is a 3. Okay, so that was this one, the starting point. Okay, we then go down to the numerator, or the minimum. Okay, so the minimum is 3/4 away from the starting point. So what is 1 plus 3/4? That would be 7/4. So my minimum is going to be at 7/4 and a 1 for the y-coordinate. If I travel another 3/4, that's going to put me at 10/4. So the point in the middle of the very center of the graph, that is going to be at 10/4 and 3, because the 3 is the midline. If I travel another 3/4, that'll put me at 13/4. And so that's going to be the 4th point. It's going to be 13/4. And the y value this time is at the top, so it's going to be at a 5. And then one more to get to the end. We're going to add another 3/4, which is 16/4, which 16/4 is actually 4. And so my 5th point, where it ends for this one period, is going to be at 4 and 3. Okay, so these are the 5 points that kind of highlight the middle and the top and the bottom of the graph. And again, the width, the distance between those points is just taking the whole period, which in this case was a 3, and dividing it by 4. Okay, and that will always work, even if the period is in terms of pi. It will still, you'll take the period, divide it by 4, and you can figure out how far apart they are. Okay.